So let's talk about balancing chemical equations. We mentioned the law of conservation of mass just a little bit ago. Matter or atoms. We talked about it in terms of atoms too, but matter can be neither created nor destroyed. I'm just going to write neither. So let's look at this chemical equation right here. And the way it's written right now, with just blanks sort of in front of each of those chemical formulas, H2 and O2 making H2O, if we don't have any number in front, or if we have a blank or something like that, that means 1. So, as it is right now, 1 hydrogen, 1 O2, 1 H2O. And look at what that's representing. 1 H2 formula, okay? 1 O2 formula, 1 H2O formula. And it looks like this. Now, think back for just a second. Why did we call this H2? Why not just H? Why did we call that O2? Do you remember what those elements are called? Because of those 2's there, or those 2's are there because those elements are diatomic elements, which means that a sample of either of those pure elements exists as pairs of bonded atoms. An H2 molecule looks like this. An O2 molecule looks like that. An H2O molecule looks like that. Okay? In fact, let's write molecule right here. Molecule. Not mole. Just molecule. Okay? And that's what this represents. But the thing is, we have violated the law of conservation of mass right here, if this were actually to take place. What's the problem? I've got, for conservation of mass, you have to count atoms. So, look what's here. 2 H atoms, 2 O atoms. Okay, that's what we all had. But over here, we only made 1 water molecule. So, something's wrong. We're missing an O atom. But we're not just going to draw an O atom over here, because that's not what this chemical equation says. It doesn't say that just O is a product. It says that only H2O is a product. So there has to be some way to get this to work out so that we're not gaining or losing any atoms. And to do that, we are going to modify these coefficients. The coefficients are the numbers in front of each of those formulas. So there, and there. And the coefficient is just how many of those formulas that we have. Okay? If it's a molecular substance, how many of those molecules. So when it's blank, or if we have ones like that, we have just one of those molecules. So the first thing we can see, though, and what I'm going to do here, I'm going to separate the reactants and products, because both of those sides are going to have to be the same. Okay? We're going to add up the atoms on each side. Okay? We've got 2 H atoms over here. We've got 2 O atoms. Over here, we've got 2 H atoms, but only 1 O atom. Law of conservation of mass says that these numbers have to match these numbers over here. And the problem is 2 O atoms can't just become 1 O atom. But the only way to balance, the only way to get those numbers equal is by changing those coefficients. We're not going to add or remove substances. We're not going to change formulas. You might be tempted to just say, well, maybe it's H2O2. But the thing is, it's not. We've already told you that H2O is the product, and we can't just change it into a different substance. Okay? H2O2 is hydrogen peroxide. Okay? So you cannot change the formulas. Make sure your formulas are correct before you attempt to balance. And we'll talk all about how to do that in a little bit. So the only thing that we can do is change this coefficient. What if I say 2 H2O molecules? Well, what that actually means is that instead of just having this one molecule right here, now let's draw another one. Water looks like that. It's an O with two H's sort of attached. So when we have 2 H2O, that's what we're talking about. Okay? Now we have 2 water molecules. That's what this number 2 means. We've got one here, one there. 2 water molecules. So whenever we change the coefficient, though, that changes the number of atoms over here, and really this number gets multiplied into those formulas. So 2 H2Os means that now I have 2 times 2, I have 1, 2, 3, I have 4 H's, and I have 2 O's. And that gets our O's taken care of. 2 O's over here, 2 O's over here, but now we screwed up the H's. But that's not a big deal because we can change that coefficient too. Let's say we now have 2 hydrogen molecules. Look like that. Didn't draw that very well. Okay. Close enough. Okay. This number 2 right here means that we have 2 H2 molecules. So updating that, 2 times 2 is 4 H atoms. Now our equation is balanced. So the key to balancing is counting atoms, change coefficients only, do not change formulas. Yeah, I already wrote that there. Okay. Count atoms, change coefficients only, get the atoms to match on both sides in order for it to be balanced. So that was a sort of long and drawn out explanation for how balancing works, but the mistakes that I see students make are consistent with not understanding what this number means. Okay? That this number is how many of that formula we have. So literally 2 H2O means that we've got an H2O and then I've got another H2O. I've got 2 H2Os total. Okay? O2 means that I've got just an O2. 2 H2s means I have an H2 and another H2. Okay? If I had 3 H2Os over here, I would multiply that by each of those formulas to figure out how many atoms there are. But literally all that means is that I've just got 3 of those formulas, if that were a 3 there, for instance. Okay, so that's our general procedure for balancing. We're going to total up the number of atoms on both sides and change the coefficients until they get to be the same. So this will involve a couple of little tricks and hints in order for you to be able to do this efficiently, though. So for this first one here, I like to draw a little line down the middle, at least until you're totally used to figuring out the entire left side and right side. And first thing I like to do, total up the number of atoms on each side, going by elements. So C, H, and O. And if it's blank, that's the same as a 1. It's totally fine just to leave that blank. If you're in Mastering Chemistry or D2L or something like that, you should probably put a 1 in those blanks. The directions will usually tell you not to leave anything blank. Okay? But ones are fine. You can put 1s there in whenever you want if you like, but normally we leave them blank. So just totaling this up, CH4, are there 4 C's? No, there is 1 C and there are 4 H's. So 1 C, 4 H's, 2 O's. Remember, we're counting atoms over here. 1 C, 2 H's. And then another common mistake, we've got O's in both of these. You have to add up all of those O's. So 2 O's over here and 1 O over there. That's 3. So our first little trick is to leave elemental substances for last. CH4, O2, CO2, H2O. Which of those is the element here? Which of those is the elemental substance? We've got several molecules and one element. The one that comes just from one square on the periodic table, that is the element. So we're going to save its coefficient for the very end, because no matter what we put here, it's not going to mess up any other things. Okay? We can save that for the end because it'll be only O that we're dealing with. If in any of these molecules you've got 2 or more elements within them, that putting the coefficient in front of will change the number of atoms. So this one shouldn't be too bad, though. C looks already balanced. H is not balanced. We've got 4 H's over here, but we only have 2 H's over there. So we have to figure out what coefficient we need there that will multiply into that formula. Okay? So what times 2 equals 4? Well, let's put a 2 there. And anytime you change a coefficient, you need to update your totals, because now we have 2 times 2, we have 4 H's. We have 1, 2, and then 2 times 1, right? Another 2 O's over here. 2 H2O's, that's just like this. Right, up there. So how many O's do I have now? 2 over here, 2 over here, 4 like that. So then what's the last thing that we need to do to get it to balance? How many of these O2's do we actually need? Well, we need 2 again. Because 2 times 2 is 4. 1, 4, 4, 1, 4, 4, then it's balanced. Right? So here's another issue that comes up pretty frequently, maybe almost about half of the time on a certain type of chemical equation that we're balancing. I call it sort of the even-odd issue, and it's hard to explain what that exactly means, so I'll just kind of have to show you here. Let's separate the two sides. Let's C, H, and O. Total those up. C, H, and O. So C4, H10, O2. 1, 2, 3. Okay? So we're again going to leave O2 for the end, just like we did before. Let's start with C. Could start with H. Okay? Doesn't really matter, but go one element at a time and see if there's a coefficient that you could write that that changes that. Now remember, we're not adding. We're not using those coefficients to add. Those coefficients will multiply into those formulas to tell you the total number of atoms over on that side. Okay? So what do I have to put here? What multiplies into that single C to get 4 C's total? Well, 4. But now we have to update C, because I got 4 of them. Do I have 8 O's? Close, but not quite. Don't forget about the O that's over here. I've got 8 in this one, and then 1 more in that H2O, so I've got 9 O's. All right. But don't worry about O's yet. We're going to save O for the end. What about H's? What do I have to put here to get H's to balance? What do you think? What X times 2 will equal 10? It's going to be 5. So 5 H2Os will give 10 H's total. And then again, let's update this. Count all the O's over here. 4 times 2, 5 times 1. That is 8 and 5, which I believe is 13. Sometimes our errors are arithmetic related in this. That happens to everybody, so double check your addition. So here's our even odd issue. There is no whole number that I could put in this box right here in order to get a total of 13. No matter what whole number I put here, we're going to have double the atoms, which makes it an even number. So that's the even odd issue. So when we have an odd number of atoms on one side, and we're restricted to an even number on the other side. Okay? So in this even odd issue, the thing to try is doubling all other coefficients. This is the coefficient in question right here. Let's not make a 0, let's put a box there. Okay? That's the coefficient in question. In order to get this to work, let's try doubling all the other coefficients. So don't forget this one. This blank, what is that actually? That blank is actually a 1. So let's double it. Let's double the 4. Let's double the 5. Let's update our totals. So 2 times 4 is 8. 2 times 10 is 20. 8 times 1 is 8. 10 times 2 is 20. So if you did that right, those ones should still be okay. 8 times 2 is 16, plus 10 is 26. And again, if you did that right, you should end up with twice as many atoms over on that side. Now we have a whole number that we can put in here that will give us 26. It's going to be what this one was. It's going to be 13, because 13 times 2 is 26. So that's just one way of doing it. Another way of doing it would have been putting a fraction in here before we doubled all those. We could have put 13 halves, or what's 13 halves? That's 6.5. We could have done that, but a properly balanced chemical equation has only whole numbers, so we would have had to multiply through the whole thing anyway to get them into whole numbers, so that's fine. So they're all whole numbers. Okay? Make sure all coefficients are reduced to the simplest whole numbers also. Sometimes if you're doing a little bit of trial and error, you may end up with reducible coefficients. That's fine, but in your final answer they need to be reduced. So say you had coefficients of like 2, 2, 2, 4, or something like that. Okay? Better reduce those to 1, 1, 1, 2. Entering coefficients for balanced equations in like a homework system or a quiz or something like that, you will be expected to use the simplest possible coefficients. All right, here's another one. If you do the experiment 8 pre-lab questions in the lab packet, here's one that sort of comes from that, 2B. Number 2B, and those pre-lab questions in the lab packet. You do the pre-lab questions just for a little extra practice. Let's see how this one works. This little trick is sort of a last resort, I suppose. You can try those other things. There are a limited number of occasions where this one is useful, but it can be very helpful in particular sort of pesky balancing situations. So if an element appears in one compound on each side, balance that element first. So here we only have one compound total, but then look at this, 2 compounds. I've got H in both of those compounds, okay? I've got P in both of those compounds, but O is only here. So in other words, O is in this one, O is in this one. O only makes one appearance on 2 sides of the equation. So in order for that element to balance, the only way to balance that is by sort of using the least common multiple for a total. So if I have 3 and 4, sort of the least common multiple would be making 12 total. So what I can do, whatever coefficients I put out in front of those, they have to make O balance. 3 times 4 is 12. 4 times 3 is 12. Okay. So H, P, O, H, P, O. But do you get how, since I have O here, and the only place O shows up on this whole side is right here, then those two coefficients must make O balance, and you can use a least common multiple for that. So a lot of times that will just pretty much take care of it. If we do 12 H's, 4 P's, 12 O's. Okay. For H's, 9 H's, but then 3 more, so 12 H's over there. 3P over here plus 1 more P, that's 4. And then 12 O, so it's balanced. You would be going back and forth a whole lot of times trying to get that to balance if you didn't take the least common multiple of O into account on that one. So maybe this is a trick that you do if you've gone sort of back and forth at least a couple of times and you're having trouble. Maybe see if you can identify an element that only shows up once on each side, that's in only one compound on each side, and then get that one balanced first. Another trick that will save you a tremendous amount of time if your compounds contain polyatomic ions is that if the polyatomic ions are identical on both sides, group them when counting. So for instance, here is sodium sulfate. I have a sulfate ion that also shows up over here. Sulfate and sulfate, okay? Here's calcium nitrate. I have a nitrate ion in here. I happen to need 2 of them in this compound, but that's just because of calcium's charge. I have a nitrate in this compound, okay? So that counts as polyatomic ions being identical on both sides. Instead of counting elements, let's count sulfates and nitrates. Okay? Sulfate isn't too helpful for us, but nitrate is. Look at this. I've got 2 nitrate ions in here. See what that subscript 2 there outside of the parentheses means 2 nitrate ions. And I've only got 1 nitrate ion in this one. So what has to go here to make 2 nitrate ions? Well, 2. So I got 2 nitrates. Now I've got 2 nitrates. Oh, but I've also got 2 sodiums here. But no need to worry. Over here, we also already have 2 sodiums. So that will usually greatly simplify things like this. You usually end up with just, 1s, 2s, and 3s an awful lot, because that's sort of what the charges are in a lot of our polyatomic ions. So, and you can also see how this would have saved time, because if we had been counting elements, look at oxygen. We've got 4 in here, we've got 6 in here, we'd have 10 oxygens, and then 7 oxygens, and 2 N's, so it's, it gets to be a pretty big mess, because oxygen is in all of those. If you're counting the elements in that would have been made that really tricky. Okay? But be very careful, you need to use elements if any of the polyatomic ions are different. Okay, so if this was sulfate, but maybe that was sulfite over here, you obviously cannot equate those to each other. You have to count the elements. You have to count S and O. Okay? Or if you had sulfate and then just S over here or something like that, okay? If a polyatomic ion just pretty much went away and left just its central element. So there are a lot of reactions. We'll be doing a lot of reactions in this chapter, especially that have these polyatomic ions that remain grouped together. Just count those polyatomic ions and balance them that way. All right, we have a chemical equations worksheet that is in the practice worksheets section of D2L. That will help you practice writing and balancing chemical equations. So part of it is just chemical equations that just need balancing coefficients. So I have some easy ones and some hard ones for you to balance. There are some of you, I'm sure, that will have no problem balancing. It'll be just sort of like a little number puzzle, and you just sort of whip through and go back and forth and get it figured out. There are some of you that will struggle with balancing. And it obviously has nothing to do with how smart you are. You're probably good at other things, but there are definitely some of you that will have real trouble with balancing and need to practice it a lot in order to get it down, because we're going to be doing a lot of balancing in the next couple of weeks. So That's going to be one of those sort of basic skills that it'll be important that you be able to do accurately and quickly. So make sure to practice that however much you need to. Another skill to have is taking a written description of a chemical reaction and translating that into a balanced chemical equation. So in this question, I want you to write the balanced equation with phase labels for the following word description. So that will require translating each of these substances into their chemical formulas. That will require so first worry about writing chemical formulas for these. To identify where the arrow is, look for sort of the verb of the sentence, right? We've got these things, they're combining to create, and now we're talking about the products. So why don't you pause for just a second, see how far you can get in writing a balanced chemical equation out of this. So starting with these formulas, okay, it's very important to get those formulas written first. Reactants, products, whenever there's and, use a plus. Okay. Don't forget diatomic elements. Will look like that. If you have a diatomic element that's just its own substance. So once you get all the formulas correct, leave space, just like we did in all of these. Anytime you write a formula, I want you to practice doing it this way, where you actually draw a line, leave a little space. So to align the formula, plus, leave a space, the formula arrow, a space, the formula, okay. If you don't do that, I know how students work. You get to writing those formulas, you have to squeeze those coefficients in, and that's where mistakes happen. So always start out, leaving that space, drawing that actual underline there. So let me see if you can do that. This is what I would do. Solid sodium. If it's just an element like that, if it's not a diatomic element, then it's just that element, Na. No charges or anything. Sodium doesn't have a charge when it's alone. Okay. Sodium would be Na plus when it's with a compound, right, or when it's part of a compound. But here, sodium, solid, look like that. And leave space. Water. Remember we said water is a place where we can use that liquid phase label. Combine to create sodium hydroxide solution. So leave a space for a coefficient. Sodium, and then hydroxide was a polyatomic ion. If you're ever not sure how to write one of these formulas, from the name it's going to be very helpful, especially in a little bit, to write what those ions are. Sodium is plus and hydroxide is OH minus. So all that formula needs to be is NaOH. Solid. And hydrogen gas. The thing is, when it's hydrogen is an element, it's not just H, it is a diatomic element, so it's H2. Okay. So that's sort of our first step. Get those formulas written. Don't worry about balancing until you know that all of your formulas are written correctly. And then we can worry about balancing. Na, H, and O, Na, H, O. Looks like 1, 2, 1, 1, H's. 1, 2, 3, 1. So, obviously we've got an issue with H. We can't do a least common multiple with that because we've got H in both of these substances. So, I don't know of a way of sort of writing this little trick, but the idea here is that no matter what, we're going to need more H's over here. Okay, this can't just be one. We're going to need more H's because we literally have more H's over on that side. So we're going to somehow need more. So let's just start giving ourselves more H's. So start with 2 or 3 or 4 or something like that, okay, until you have enough H's, and see if then there's something you can do to balance to equal it out over on the other side. So updating the totals here, 4 total, 2 O's. Okay. And it may seem like that didn't really help us and it made the O's worse, but that actually did help us quite a bit, because now there's a coefficient I could use that'll give us 4 H's total over here. So think about that. And it's not going to be over here, because if I change that up to a 2, then I'd have 4 plus 1, I'd have 5 H's. But if I changed this one to a 2, look what happens. Well, I have 2 sodiums, but then I have 2 O's, and now I have 2 H's here and 2 H's here. I have 4 H's total. See that? That just balanced H and O for us. And then the only thing left is to get sodium. 2 sodiums over here, so I better put a 2 there, and then we're good. So at some point I'm going to think of a slick way of saying that kind of trick, but it has something to do with, if you know you don't have enough elements on one side, give yourself enough elements. Okay? Give yourself, so make a coefficient so you at least have enough of a certain kind of element. Okay? It's sort of like even odd, because that won't balance it right out, but you'll at least have enough, and then maybe you can add something on the other side in order to get everything equal. So this is the other part of this, oh, set it up here. Yeah, the chemical equations worksheet, where I have word descriptions, and we've written the chemical equations for that. Okay? If this sort of thing made total sense to you and you did great with that, maybe you should just practice a couple of those to make sure you can do it. If you had a little trouble with this, I would consider it mandatory that you go through this entire worksheet and make sure that you can do that, especially because in lab, we will be doing something very similar to this. This is experiment 8 in lab, where you'll be taking a word description, writing balanced chemical equations. So get practiced up on that before lab, if possible, to make that go a little better.